Greetings to everybody. I welcome you all for this learning session on ATM layers. Myself, Dr. R. Rajmohan, Assistant Professor, Department of Computing Technologies, SRM Institute of Science and Technology. In this session, we are going to discuss about the ATM layers. The purpose of this learning session is to describe the importance of ATM layers. Once the learners know about the ATM layers, they'll be able to identify the basic functionalities of different ATM layers. Before getting into this ATM layers, we'll have a brief intro about this ATM model. ATM. ATM stands for Asynchronous Transfer Mode. It is a switching technique which is used for data communications enabled through time division multiplexing. ATM networks are connection-oriented networks just similar to the TCP protocol. They are majorly used for cell relays that supports voice, video and data communications. ATM encodes the user informations into small fixed size cells so that it can be used for TDM transmission and over the physical medium. The size of the ATM cell is 53 bytes, which includes 5 bytes for the header and 48 bytes for the payload. There are two different types of cell formats which are used by the ATM model. One is user to network interface and the next one will be the network to network interface. So with this insight, we'll get into the ATM reference model. So this figure depicts the ATM reference models. The major participants in the ATM model is the ATM endpoints and the ATM switches. The ATM endpoint is nothing but a user, a host, a workstation or a router. Another important thing about the ATM reference model that it includes the major layers such as the ATM adaptation layer, the ATM layer and the physical layer and of course the upper layers. The ATM switch consists of only two layers, that is the ATM layer and the physical layer. The ATM switches are high-speed networks or high-speed specialized switches which are used to process and forward the ATM cells. Its speed ranges from 50 Mbps to 2.4 Gbps. So with this insight in the ATM reference, we'll jump into the ATM protocol stack. This figure depicts the ATM protocol stack as a three-dimensional model. We can also see that this ATM protocol stack includes the upper layers, the user management, the control management, the management plane, the physical layer, the ATM layer and the ATM adaptation layer. In depth, we can notice that the physical layer is being divided into two sublayers, the TC sublayer and the physical medium sublayer. And of course, the ATM adaptation layer is also divided into two sublayers. One is the CS sublayer and another one is the SAR sublayer. Along with that, we can notice the control plane, the user plane and the management plane decides the core functionalities of the ATM protocol stack. In this figure, we can also notice that the ATM protocol stack has a similar model resembling to the OSI protocol stack. In depth or in particular, we can say that the data link layer and the network layer of the OSI stack has a major similarity with the ATM layers, particularly the ATM adaptation layer, the ATM layer and the physical layer. Next, we'll get into the ATM protocol stack functionalities. The functionalities of the ATM protocol layers are categorized into user plane, control plane and management plane. Both the user plane and the control plane are divided into four layers of the ATM protocol stack. Namely, the upper layer protocol, the ATM adaptation layer, the ATM layer and the physical layer. The user plane handles the user information and the required association controls such as error control and flow control. The control plane takes care of all the call and the connection related control signals. The management plane is divided into plane and layer managements. The plane management manages the whole system functionalities. The layer management takes care of the management of all resources, interlayer coordination, parameter management of the protocol entities. This is how the ATM protocol stack functionalities are defined. Next, we'll get in depth into the ATM layers. The ATM reference model is comprised of three layers, namely the physical layer, the ATM layer, and the ATM adaptation layer. Now we'll look upon into each of these layers with a deep inscribed descriptions. First, we'll see about the ATM adaptation layer, or shortly we call them as AAL. This ATM adaptation layer provides the interface between the high-level protocols and the ATM layers. Four types of ATM adaptation layer protocols are available, such as AAL1, AAL2, AAL3/4, and AAL/5. Each of these AAL protocols supports specific services in the ATM network. Most of the ATM equipment vendors adopt AAL5 for data communication services. The AAL consists of two sublayers. One is convergence sublayer, that is CS, and segmentation and reassembly sublayer, that is SAR. The CS sublayer, that is the convergence sublayer, enables ATM system to offer distinct services like file transfer, video on demand, and providing the standard interfaces for the convergence of the data. The SAR, that is segmentation and reassembly, it breaks the packet into cells on the transmission sides and put them back again together at the receiver side. Apart from that, it also manages the segmentation process and the reassembly process at the transmitter side and the receiver side. So to conclude, we can say that this ATM adaptation layer transmits a 48-byte segmented payload to the next layer, that is the ATM layer. Now we'll see upon how the ATM layer works. The ATM layer deals with the cells and cell transmissions. It defines the layout of a cell. It deals with the establishment of the connections and the release of virtual circuit connections. Also, congestion control is dealt in the ATM layers. Apart from this, header generation and header extraction process is also carried over by the ATM layers. In general, we can refer this ATM layer as a mixture of OSI data link layer and the network layer. This ATM layer forwards a 5-byte header which is generated in the ATM layer along with the 48-byte payload which was received from the ATM adaptation layer. So altogether a 53-byte data of ATM cell is transmitted to the physical layer. So this is how the ATM layer works. So to conclude, we can say that the ATM layer is responsible for flow control, cell header generation and extraction, virtual circuit and path management, cell multiplexing and demultiplexing processes. The next thing we are going to discuss is about the physical layer. The physical layer provides the transmission channel for ATM cells. The received ATM cells are transferred into a continuous bit streams after adding the transmission overheads to them. The physical layer is divided into two sublayers. One is TC, that is transmission convergence sublayer, and another one is PMD, physical medium dependent sublayer. The transmission convergence sublayer is responsible for header sequence generation, cell delineation, frame generation, and recovery. The physical medium dependence sublayer is responsible for bit timing and encoding and decoding of bits. So to conclude, we can say that the physical layer is responsible for cell rate decoupling, header checksum generation and verification, cell generation processes, packing and unpacking of cells, frame generations, bit timing process, and physical network access. This is how all the three ATM layers functions. Next, we'll see the summarization of this session. So as of now, we have discussed what are the different ATM layers available, that is the physical layer, the ATM layer and the ATM adaptation layer. So to conclude that, we can say that the physical layer, so this layer corresponds to the physical layer of the OSI model. At this layers, the cells will be converted into bit streams and transmitted over the physical medium. Apart from this, the physical layer has two sublayers, namely the physical medium dependent sublayer and the transmission convergence sublayer. The next ATM layer is the ATM1. This layer is comparable to the data link layer of the OSI model. It accepts a 48 byte segments from the upper layer protocols or upper layer models and adds a 5 byte header which is generated here to the each segments and converts that into a 53 byte cells. This layer is responsible for routing of each cell, traffic management, multiplexing and switching process. The next layer is the ATM adaptation layer or the AAL. This layer corresponds to the network layer of the OSI model. It provides facilities to connecting with the existing packet switching networks to the ATM networks and utilize their various services. It accepts the data and converts them into fixed size segments. This layer has two sublayers. One is the convergence sublayer and the segmentation and reassembly sublayer. So now we have came to the end of the session. I hope you have enjoyed and learned a brief insight into this different ATM layers. These are the references which I referred for the learning session. I once again thank you all the learners who have viewed for this session. Thank you all.